So let's start today's first question. So question number 1. Let x1, x2, xn be a random sample from a uniform distribution U 0, theta, where theta greater than 0 and xn equal to maximum of x1 to xn. Now consider the following statement. Means statements are 1, that is xn is complete, 2, xn is sufficient, 3, xn is unbiased estimated for theta, and number 4 is n plus 1 by n xn is um VUA for theta. So let's check the following statements one by one, and we have to find that which is among them is not correct. So to check its completeness, we have to use the factorization theorem. That is, let's write the joint distribution of this n variable, that is f of x is I is xn, the maximum number should be less than equal to theta, is a one function of x bar, and pi equal to 1 to n, another index function I xi greater than 0. It should be greater than 0, otherwise the all function will be, and is a function of x bar. Now here, where I xn less than equal to theta is 1 if xn less than theta, and it is 0 elsewhere. And similarly, I xi greater than 0, function of x bar is equal to 1 if xi greater than 0 or 0 elsewhere. Now from the equation 1 we can write that this is the function that only depend on the random variable x bar, and this is the function that the random variable x bar and the xn and theta, and this is the variable which only depend on the random variable. So we can write f x bar as h x bar into g1 xn comma theta. here g1 is, this is the I xn less than equal to theta x bar, and this function is this function. So from here you can get that since you can write the joint distribution as hx into g1 xn, therefore by the factorization theorem, we can say that xn is a sufficient statistic for theta. So it is a sufficient statistics. Let's check for its completeness. So for completeness we have to check, we have to write its distribution function. So let's first calculate the distribution function. What is the probability that xn less than equal to x, that means its cumulative distribution function, it should be, if xn less than x, then every other variable should be less than equal to x. x1 xn equal to x, so up to p xn less than equal to x. And since all variables are random variable and they taken from a uniform distribution, so it will become x by theta to the power n for 0 less than x less than theta. Now then the probability density function of the x of the nth statistics will be n theta to the power n x to the power n minus 1. Now check its completeness. So it will be that and 0 or 0 less than x less than theta, 0 elsewhere. Now for completeness we have to check that if expectation of g of xn is 0 for all theta greater than 0, then we have to prove that the gxn is 0. So to prove that we have to use this distribution function, that is 0 to theta g of x n theta to the power n x to the power n minus 1 dx equal to 0 for all theta. This, since theta is greater than 0, so for in every interval it tells us that 0 to theta gx x to the power n minus 1 dx should be 0, which is only possible if gx is 0. So that means xn is complete. Now let's see the expectation of only xn. What will be the expectation of xn? That x 0 to theta n theta to the power n x to the power n minus 1 dx. So that will be n theta to the power n 0 to theta x to the power n dx. So that will be n theta to the power n into x to the power n plus 1 by n plus 1 0 to theta. So it will be n by n plus 1 theta. So it is then it is not an unbiased estimator for theta, because expectation of xn is not equal to theta, so that means it is not an unbiased estimation. estimated value for theta, but it is sufficient and complete. Then this will be n plus 1 by n xn's expectation will be theta. That means this xn by n plus 1 by n xn is the unbiased estimator for theta, and it should also be a complete estimator and also be a sufficient estimator for theta. That means by the Rao-Blackwell theorem we can say that this is n plus 1 by n xn is UM v UE for theta. So that means these three options are correct. First option is correct, we have checked. Second option is correct. Third option is wrong, and fourth option is correct. So that's it. Now let's move toward the next question. So next question is question number 2. Let x1, x2, xn PID random variables of binomial 1, p. Let t is a statistic, that is summation of I equal to 1 to n xi, and psi p is variation of x1, then which of the following is true, where A is t into t1 minus t is UMV UV, B tn minus t by n into n minus 1 is UMV UE, C nt minus t square by n into n minus 1 is UMVUA, or T, that is nt minus t square by n into n plus 1 is UMVUA. So I'll check that. Hello. So first, so it is given that x1, x2, xn is a binomial 1, p, then so the variance will be p into 1 minus p. Therefore the joint distribution will be f of x bar will be pi I equal to 1 to n p to the power xi 1 minus p to the power 1 minus xi, that you can write as p to the power summation of xi I equal to 1 to n 1 minus p to the power n minus summation of xi. So you can write it as p by 1 minus p to the power summation of xi 1 minus p to the power n. Now here you can take this h x bar which is equal to 1 into this function g1 g1 p xi. So that means here p is the parameter and summation of xi is the estimated. So that from the factorization theorem you can see you can tell that the summation of xi or t, the statistic summation of xi, is a sufficient statistic for this parameter p. Now what this t, what distribution t follows, look at t is the sum over of xi I equal to 1 to n, then it should follow the binomial distribution with n and p. So what will be its probability distribution? Now check its completeness. So completeness means the expectation value of t equal to x, expectation of, you have to check the expectation of gx equal to 0, then gx should be 0. That means summation of I equal to 1 to n gx n cx p to the power x 1 minus p to the power n minus x should be 0. So that gives summation of gx n cx p by 1 minus p to the power x and 1 minus p to the power n to 0. So this will give summation of gx n cx p by 1 minus p to the power x equal to 0 for all p belongs to 0, 1. Since one is polynomial, since this is a polynomial of degree n in the variable p, and the equation is true for all p belongs to 0, 1, so gx has to be equal to 0 for all x equal to 0, 1 n. So that means xi is also complete. Okay, now I have to check what is the expectation of t into t minus 1. Since this follows, t follows a binomial distribution of n degrees of freedom, so so n1, so that will be n into n minus 1 into p square. So what will be, and you also know the expectation of t will be n into p. So that means if I subtract e expectation of t minus t into t minus 1 from expectation of t, will get n p. Okay, another thing, so okay, do this instead of do this. So if I do that, the expectation of t by n subtract et t minus 1 by n into n minus 1, what you will get? You will get p minus p square, that will be p into 1 minus p, that is psi p. And psi p will be expectation of t by n minus t minus 1 by n into n minus 1, that is expectation of n into n minus 1. This will be t n minus 1 minus t minus 1. So by take t common, t n minus 1 minus t minus plus 1 by n into n minus 1, it will become expectation of t n into n minus 1. So this is, since the t is a complete and sufficient, and also t n minus t by n into n minus 1 is a unbiased estimator for psi p, that means this estimator n minus t by n into n minus 1 is UMVUE for psi p. That's it. Now let's see the question number 3. A manufacturer of soft drink beverages is interested in the uniformly of the machine used to fill cans. Specifically, it is desirable that the standard deviation sigma of filling processes be less than 0.25. Fluid ounces. Otherwise there will be a higher than allowed percentage of cans that are underfilled. Assume that fill volume is approximately 0.05 normally distributed a random sample of 20 cans, a random sample of 20 cans results in a sample variance that is z square equal to 0.0225. A 95% confidence interval of sigma square is, we have to find the 95% interval. So let's say, so here n is equal to 20, s square is equal to 0.0225, alpha equal to 0.05. The state statistic is n minus 1 s square by sigma square, which is a chi square n minus 1 degrees of freedom random variable. Therefore the confidence interval will be is n minus 1 s square by chi square alpha by 2 n minus 1 and n minus 1 s square chi square 1 minus alpha by 2 n minus 1, which is, let's put all two things together. So this is n minus 1, 19 into 0.0225, and this is 32.852 19 into 0.0225 by this is 8.9065. So that is approximately 0.013 to 0.048. Here this is that, so this is the answer. So now let's go toward the question number 4. A random sample of 16 excuse me airline passenger engine in an airport shows that the mean time spent waiting in line to check in at the ticket counter at the ticket counter. At the ticket counter is 30 minutes. Assuming that waiting time in line to check in at the ticket counters for all passengers follows normal distribution with standard deviation 3 minutes. Find 95% confidence intervals for the mean time spent in line to check in. Let's see. So here n is given 16, mean is given 30, and alpha is 0.05, and population standard deviation, that is sigma is 33. Therefore a 95% confidence interval for the mean time spent in line to check in is x bar minus sigma by root n z alpha by 2 comma x bar plus sigma by root n z alpha by 2. This is, if I put all together, 30 minus 3 by 4 into 1.96 comma 30 plus 3 by 4 1.96. This is basically 28.53 to 31.47. So that's it. So that is the solution of the question 4. Now let's see the question number 5. Question number 5, that is a random sample of 20 acre give a mean yield of wheat production equal to 41 bushels per acre with a standard deviation of 3 bushels. Assuming that the yield of wheat production wheat per acre is normally distributed 95% confidence interval for population mean. So here it is given that n equal to 20, x bar is 41 and sample means s is 3. The population standard deviation is unknown, so we have to use the t, that is then the we know that root n by x bar minus mu by s follows a t distribution with degrees of freedom n minus 2. From here we will get that the range will be x bar minus s by root n t alpha by 2 comma n minus 1 to x bar plus s by root n t alpha by 2 comma n minus 1. So it is 41 minus 3 by root 20 into this value will be 2.093 to 41 plus 3 by 20 to 2.093. So that is basically 39.596 so 42.404. So that is the interval range. So that is the question number 5. Let's go toward the question number 6. Question 6. Let x1 x2 xn p a random sample comma normal population with mean mu and standard deviation sigma. Find the confidence level for interval x bar minus 0.2 sigma by root 10 to x bar plus 0.2 sigma by root 10 of mu, where x bar is the sample mean. So let's see. So since the x bar minus mu root 10 by sigma follows on standard normal distribution, then we can say that x bar minus 0. We can calculate what is the probability that 0. X bar minus 0 to sigma 0 to sigma by root 10 is less than mu less than x bar plus 0.2 sigma by root 10. We can calculate this probability first. So these will be, let's calculate it in this way, that probability. So here x bar minus 0.2 by root n sigma less than mu, then x bar minus mu less than 0.2 sigma by root n, that is root n x bar minus mu by sigma less than 0.2. From this and from this will be square plus 0.2 sigma by root n is greater than mu. That means x bar minus mu root n by sigma is greater than 0.2 minus 2. So that means minus 0.2 greater than z less than 0.2. So this probability one can calculate, and this is nothing but 0.1585. So the confidence interval will be 15%. So that's it. That was the question number 6. Now let's see question number 7. A local college has a self-service soft ice cream machine. The cafeteria provides bowls that can hold up to 16 ounces of ice cream. The food service manager is interested in comparing the average amount of ice cream dispensed by male and female students. A measurement device was full the random sample, so a random sample of 30 mils, a random sample of 30 mils, sample of 30 males and 40 female who get ice cream or selected, and the average of these 30 male and 30 males is average, is samples average is 10 and 8 ounces for male, female student respectively. Assume that they are normal. Assume that the ice cream students are normally distributed, and with standard deviation. Normal, the population standard deviation 1 for male, standard deviation for the female is 1.2. 1.2 for female. So find a 95% confidence interval for the interval difference mean of ice cream amount dispensed by all female male. So I have to calculate the difference of the means. So that means we have provided n1 equal to 30, n2 equal to 40, x bar is 10, y bar is 8, sigma 1 square is 1, sigma 2 square is 1.2 square 1.44, and alpha is 0.05. So the 95% confidence interval for mu1 minus mu2 will be this x bar minus y bar minus z alpha by 2 root over of sigma 1 square by n1 plus sigma 2 square by n2 excuse me, x bar minus y bar plus z alpha by 2 to root over sigma 1 square by n1 plus sigma 2 square by n2. So this is nothing but this is 1.48 to 2.56. So this is the range. So this is the answer of the question 7. Now let's go toward the question 8. Let's solve the question number 8. In a batch chemical process used for printed circuit boards, BOARDs boards to different catalysts are being compared. To determine whether they require different immersion times for a removal of identical quantities of photoresist material. Twelve batches were run with catalyzed 1, resulting in a sample mean immersion time of 24.6 minutes and a sample standard deviation time is 0.85 minutes. And 15 batches were run with the second sample with the catalyst 2, resulting in a mean immersion time mean immersion time 92.1 minutes and standard deviation of 0.99 minute. Find the 95% confidence interval difference means immersion times of catalyst 1 and catalyst 2. So let the two and assume that the population follows a normal distribution. So they both follows the normal distribution with mu1 sigma 1 square, another is n mu2 sigma 2 square. Now in this case the known variables are n1 is 16, n2 is 15, x bar is 24.6, y bar is 22.1, s1 is 0.85, s2 is 0.98. No standard deviation, population standard deviation is not known. So in this case pooled sample variance, pooled sample variance s square is n1 minus 1 into s1 square plus n2 minus 1 s2 square by n1 plus n2 minus 2. Therefore a 95% confidence interval of mu1 mu2 is x bar minus y bar t alpha by 2 comma n1 plus n2 minus 2 root over of 1 by n1 1 by n1 plus 1 by n2 into s square 2 x bar minus y bar plus t alpha by 2 comma n1 plus n2 minus 2 root over of 1 by n1 plus 1 by n2 into s square. So if I put all the value, it will become 1.764 to 3.236. That's it. Now let's move toward the question number 9. There is question 9. Suppose population 1 and 2 follows the 1 and 2 follow normal distribution with mu1 sigma 1 square, another in mu2 sigma 2 square respectively. Two independent random sample size n1 equal to 15 and n2 equal to 20 drawn from population 1 and 2 respectively. It is observed that sample variance R S1 square is 4.9 and S2 square is 3.6 respectively. Find a 90% confidence level for sigma 2 square by sigma 1 square. Let's do it. So given that n1 equal to 15, n2 equal to 20, s1 square is 4.9, s2 square is 3.6 and alpha is 0.10. So 90% confidence level for sigma 2 will be a F distribution, so that will be s2 square by s1 square f1 minus alpha by 2 comma n1 minus 1 comma n2 minus 1 to s2 square by s1 square f alpha by 2 n1 minus 1 to n2 minus 1. So now put all the values. That will come as 0.306 to 1.657. So that's it. Now let's move toward the today's last question. So that is question 10. Question 10. Let's do it. Here it is asked that let x1, x2, x3 be a random sample from a continuous distribution with PDF AFX is e to the power minus x minus mu and x greater than mu and 0 elsewhere. Let x1 be the smallest of x1, x2 and x3 and c greater than 0, then x1 minus c comma x1 is a 95% confidence interval for mu. Then find the value of mu. Find the value of mu. Let's do it. So it is given that probability that x1 minus c less than mu less than x1 is 0.95. Or from here you can write that x1 minus c less than mu, that means x1 minus mu should be less than c, and from here mu less than x1 mu, from here you get 0 x1 mu. So you can write these, that is probability that 0 greater than x1 mu less than c is 0.95. Now assume that assume not this x1 mu will be the minimum of among the x1 minus mu, x2 minus mu and x3 minus mu, minimum of this thing. So let x1 minus xi minus mu is yi. Then the probability density function of the PDF of yi will be f of yi mu will be e to the power minus x, where x greater than 0 or 0 elsewhere. Then probability that y1 less than equal to x will be that 1 minus probability that y1 probability that y1 greater than x, so that means all the variables should greater than 1, so p of y1 greater than x, y2 greater than x and y3 greater than x. So this is nothing 1 minus c to the power. So if there were n variables, so it will goes from n, so here 3 variables, so minus 3x, 1 minus 3x. Then probability that y1 x will be derivative of e, so 3 e to the power minus 3x. Now you see that probability that 0 greater than y1 less than c will be 0.95, and we get the distribution. So let find the probability, this probability, this will be 0 to c if y1 x tx, that will be 3, 0 to c e to the power minus 3x tx, so will be 3, so this 3 into e to the power minus 3x by minus 3, 0 to c, so this is 1 minus e to the power minus 3c. So from here we get 1 minus e to the power minus 3c equal to 0.95, e to the power minus 3c equal to 0.05, so that is minus 3c equal to 1 by 20, so 3c is log 20, so c is 1/3 log 20, so that is approximately 1, so the value of c is 1. So that's it. Now that's all for the today's session. Now we will again meet in the next Saturday at 3 p.m. so that's it. Bye. Okay, now